So we're going to begin our coverage in this lesson by motivating the need for Java futures. And I'll explain what the future pattern is, and I'll also talk about what the Java future interface is. And we'll talk about this in a lot of detail, but in a nutshell, a future provides a means to retrieve the result of a computation that's being executed asynchronously without requiring indefinite blocking of the client thread or the caller thread. So why do we need futures, or what can futures do for us? If you refer back to the check primality class that we talked about in a recent lesson about implementing closures with Java Lambda expressions, you saw how a closure could be used to store the results of a computation that runs in the context of a Java thread. Here's an example of this. This is from the EX6 case study, where we have a main thread, and the main thread starts a background thread, which is this check primality closure object. And the computation there will check the primality of a large big integer asynchronously after the main program's client thread has started the background thread. So things are up and running in the background. And then the client thread will block until the result is available. That's essentially the way that the code was designed in that case study EX6 that we looked at before. There were some useful features provided here. The ability to have computations running asynchronously was useful. The ability to package these things up into an object was useful. The ability to get back a result from a thread that's executing through the use of closures and so on was useful. But there were two limitations. The first limitation is that the behavior of the check primality class was hard-coded. Hard coding is generally not a desirable thing, especially if there are better alternatives. And in particular, the check primality class only checked the primality of an integer, or a big integer in this case, even though the design can be generalized. So that was one of the limitations with this approach. The second limitation was that the getResult call that the client thread called to get the result of the computation that was running in the background could block indefinitely, waiting for the computation for primality to complete. And there's a couple problems here. First, the computation might just take a very long time, and we may not want to wait that long. So it might be nice to kind of bail out early and say, sorry, I don't want to wait forever. I want to bound the amount of time I want to wait. And likewise, it probably wouldn't be the case that primality checking would take forever. It'll eventually converge, though it could take a long time. But there could be other computations that would use similar approaches that might run forever. We want to avoid having clients blocking indefinitely, waiting for something to finish. So given those limitations, what can we do to fix them? And of course, what we're going to do to fix them is we're going to talk about how to apply Java futures and some patterns and some Java elements that are associated with these patterns, how we can apply these things to address these two limitations. So we're going to address these limitations in two ways. We're going to revise and refactor and generalize the check primality class. The first thing we're going to do is we're going to apply something called the active object pattern. And the active object pattern appeared in the Pattern-Oriented Software Architecture Volume 2 book. I was the lead author of that book. You could read about that particular pattern at the link at the bottom of the slide. And this pattern decouples the execution of a method, the thread in which a method is executed, from the thread in which the method is invoked. And that allows the active object, or the thread that's executing the method, to be different than the thread that invokes the method. So that's one of the patterns we're going to apply. We're also going to implement a variant of this pattern, which is going to be called active object. No surprise there. And this particular implementation is going to leverage some cool modern Java features, such as virtual threads, and also the functional interface that we've talked about before. So you'll be able to pass a function to the active object. It will then do the computations in the background and will provide results at some point once the computations are done. And you can find the source code in the link at the bottom of the slide. The other thing we're going to do here is we're going to apply the future pattern as well as the Java future interface to avoid indefinitely blocking the client, the calling thread, because that's going to be undesirable, of course. So the future pattern is also a pattern that appears in some of the pattern-oriented software architecture books, in particular the Pattern-Oriented Software Architecture Volume 4 book. And the future pattern's intent is to provide a so-called virtual data object that either blocks or does not block clients when they try to get the contents of the object before its concurrent computation completes asynchronously. So that's the pattern. We'll talk more about that pattern and walk through some examples here shortly. There's also an interface that's in Java that's been around for quite a number of years, almost 20 years at this point, called the future interface. And as we'll see, a future is a proxy that represents the result of an asynchronous computation. And it's got some methods that we'll talk through that help to make it possible to do things on that future, either waiting for the results to complete or to give up and cancel the results before they're complete and cancel the computation before it's complete, and so on. The active object class that we're going to look at implements the Java future interface. And that means that a caller or a client can obtain the results from the active object without blocking indefinitely. So we'll spend a lot of time kind of talking through that and seeing how to use it in the context of yet another case study. In particular, we're going to demonstrate the active object and future patterns in conjunction with the Java future interface in an upcoming case study that we'll look at here shortly. And this particular case study generalizes the earlier EX6 case study that checked the primality of big integer objects when computing RSA public and private keys. So if you go back and watch that earlier lesson, or actually there are two lessons, and then watch this one, you'll see how we generalize it and make it more useful, more abstracted, more reusable, and also more responsive because we don't block the client thread indefinitely waiting for the computations to finish. So that's the end of this part of the lesson that motivates the need for Java futures.